ski. And for my physics project, what I did, it was the same projectile project everyone else did, except I used a baseball and I used a football field for my horizontal measuring. What was nice about this was it made it both easy and convenient to calculate all the final distances and record the data. So, for my upward one, I recognized the law of gravity being 9.8 meters per second downwards, rounded up to 10 meters per second to make it easier, and then threw the ball. Once the ball reached its fulcrum, I counted in 1 Mississippi, 2 Mississippi increments until it hit the ground. For the first trial, and for several thereafter, it was around 3 seconds. So with that in mind, you can do the math and say that I must have thrown the ball at 30 meters per second upwards, because since the gravity is acting 10 meters per second downwards on it, it'll decrease by 10 at a time. So if you do the math, 30, 10 downwards in the next second, 20, plus 10, you get 60. And so that's what it would have reached by the final point of its fulcrum. Down, however, it would have also reached 30 meters per second downwards by the end of it, with the increase in gravity exponentially. Now, for the horizontal one, I did the same experiment. At first, I made a mistake by just throwing the ball as far as I could. I didn't throw it from exactly 6 feet, which is where the ball would be released. The issue with this was, by throwing it at an upward angle, it increased the overall hang time, therefore making the experiment useless and all the data I collected irrelevant. So, what I did was I redid the experiment, and I did the experiment 10 times, and I made sure I threw it straight every single time. Now, following the same rule that it doesn't matter how far an object travels or how fast it's going, it always has the 10 meters per second of gravity acting downwards on it. Therefore, it should all fall within about a second every time if I threw it from the approximate height of 6 feet or 1.8 meters. Therefore, no matter how far I threw it, I knew it would fall by 1 second, and it would hit the ground by 1 second, as long as I didn't throw it with any upward arc. It had to be completely straight. Now, what was really interesting about this was at first I threw one, and you'll see it in the recorded data, that went 69 yards. And then I also threw one later that went 82. And I was doing the math thinking, wow, this makes no sense. I don't think that my velocity could be 145 miles per hour. Or I like to pretend that it could have been, but obviously had to make the experiment more realistic. After I realized my error, I tried the experiment again and got closer to around 70 miles per hour, or approximately 32 meters per second. So after I did the experiment 10 times, I recorded the data in the table, as well as recording the data in the table for the upward angled one, and came up with the final results. These final results are the ones that are shown below in the tables, as well as all the information that's recorded in the write-up. I also answered the moon questions based on the idea that the gravity action on the moon was 1/6 that of the gravity on Earth. So that's my experiment. That's everything that went down. If you need any more information or have any questions, feel free to comment or call me back, or I don't know if you have my number, but feel free to email me. And I apologize for the occasional laugh or stutter. I have the person recording me acting like a complete silly person. Thank you so much, and I hope you enjoy my project. This is Dylan Lahotsky, fall, winter 2013, and yeah.